When installing a 100 amp submain to a pool area, the National Electrical Code, or NEC, provides options for wiring methods. Two common approaches involve the use of service entrance rated cable, referred to as SER cable, in combination with polyvinyl chloride conduit, known as PVC conduit, or utilizing PVC conduit for the entire run. Both options are acceptable, however, each presents its own set of advantages and considerations. The first option involves running SER cable from the subpanel to a junction box, often abbreviated as J-box. From this junction box, PVC conduit is then used to extend the wiring to the pool area. The second option utilizes PVC conduit for the entire run, starting from the main panel, extending to the submain, and continuing out to the pool area. When evaluating these options, consider the advantages offered by PVC conduit. Firstly, PVC conduit provides enhanced mechanical protection for the wires. This is especially important in outdoor environments where the wiring may be exposed to physical damage. Secondly, PVC is inherently resistant to moisture and sunlight, making it a suitable choice for outdoor applications such as pool areas, where exposure to these elements is common. On the other hand, SER cable offers its own set of advantages. Firstly, SER cable is generally more flexible compared to rigid PVC conduit. This flexibility can be advantageous during installation, particularly in confined spaces or where bends are necessary. Secondly, SER cable is often less expensive than PVC conduit, potentially offering cost savings in the project. Ultimately, the selection between SER cable and PVC conduit for the submain depends on various factors specific to the installation. These factors include the specific site conditions, the desired level of protection for the wiring, and budgetary constraints. To reiterate, both options are code compliant, meaning they meet the requirements of the National Electrical Code. However, PVC conduit is frequently preferred for outdoor applications due to its superior durability and resistance to moisture. That said, SER cable may be a more practical choice in situations where flexibility and cost are significant considerations. It is essential to thoroughly assess the project requirements and weigh the advantages and disadvantages of each option before making a final decision. When making the decision, consider these factors. Firstly, evaluate the environmental conditions. Determine the level of exposure to moisture, sunlight, and physical damage that the wiring will experience. Secondly, assess the physical layout. Consider the available space, the presence of bends, and any other constraints that may impact the ease of installation. Thirdly, consider the budget. Compare the cost of SER cable and PVC conduit, as well as any additional materials or labor required for each option. Here is additional information to make an informed decision. Regarding the NEC, be sure to consult Article 680, which pertains specifically to swimming pools, fountains, and similar installations. This article provides detailed requirements for wiring methods, grounding, bonding, and other electrical safety considerations. Also, refer to NEC sections pertaining to wiring methods, such as Chapter 3, which covers various types of cables and conduits. These sections will provide specific requirements for the installation and use of SER cable and PVC conduit. For SER cable, ensure that it is listed and labeled for the intended use, and that it is installed in accordance with NEC Article 338. Pay attention to the ampacity of the cable, which must be sufficient to carry the load of the submain. Refer to NEC Table 310.16 for ampacity ratings of conductors. For PVC conduit, ensure that it is installed in accordance with NEC Article 352. Use appropriate fittings and connectors that are listed for use with PVC conduit, and ensure that the conduit is properly supported and secured. Consider the burial depth requirements for underground PVC conduit, as specified in the NEC. When using a junction box, ensure that it is properly sized and rated for the application and that it is accessible for inspection and maintenance. Make sure to use listed connectors for transitioning between SER cable and PVC conduit at the junction box. Grounding and bonding are critical aspects of electrical safety in pool areas. Ensure that all metal parts of the pool structure, including the pool water, are properly bonded together to create an equipotential plane. This helps to minimize the risk of electric shock. Refer to NEC Article 680 for specific requirements related to grounding and bonding of swimming pools. When working with electricity, always prioritize safety. De-energize the circuit before making any connections or modifications. Use appropriate personal protective equipment, such as insulated gloves and safety glasses. If you are not comfortable working with electricity, it is best to hire a qualified electrician to perform the work. Here is some more information on each option and things to consider. With SER cable, you must ensure that the cable is adequately supported and protected from physical damage. If the cable is exposed to direct sunlight, use sunlight-resistant cable or provide additional protection, such as wrapping it with UV-resistant tape. Pay attention to the bending radius of the SER cable to avoid damaging the conductors. With PVC conduit, consider the expansion and contraction of the conduit due to temperature changes. Use expansion fittings as needed to accommodate these changes. Ensure that the conduit is properly sealed to prevent moisture from entering. When running PVC conduit underground, consider the potential for damage from digging or other activities. Use appropriate warning tape or markers to indicate the presence of buried conduit. Also, consider the type of soil and the potential for corrosion. If necessary, use corrosion-resistant conduit or provide additional protection. Remember that local codes and regulations may differ from the NEC. Check with your local building department or electrical inspector to ensure that your installation complies with all applicable requirements. Failure to comply with these requirements can result in fines or other penalties. It's also important to maintain accurate records of the installation, including the type and size of wiring, the location of junction boxes, and any other relevant information. This will be helpful for future maintenance or repairs. In summary, both SER cable with PVC conduit and full PVC conduit are acceptable options for a 100 amp submain to a pool area, according to the NEC. PVC conduit is generally preferred for outdoor applications due to its durability and moisture resistance, while SER cable may be more practical in situations where flexibility and cost are important considerations. Always consult the NEC and local codes to ensure that your installation is safe and code compliant. Prioritize safety when working with electricity and hire a qualified electrician if needed. Make sure the wire size used in either the SER or PVC conduit is sufficient for the 100 amp load. Refer to NEC Table 310.16 to determine the appropriate wire size based on the conductor's insulation type and the ambient temperature. Common wire sizes for a 100 amp circuit include number 3 American wire gauge copper or number 1 American wire gauge aluminum. It is crucial to select the correct wire size to prevent overheating and potential fire hazards. Consider the voltage drop in the circuit, especially if the distance between the main panel and the sub-panel is significant. Excessive voltage drop can cause appliances to operate inefficiently or not at all. Use a voltage drop calculator or consult with an electrician to ensure that the voltage drop is within acceptable limits. NEC recommends a maximum voltage drop of 3% for branch circuits and 5% for feeders. When installing PVC conduit, ensure that it is properly reamed to remove any sharp edges that could damage the conductors. Use a conduit bender to make smooth, gradual bends in the conduit. Avoid sharp bends, as they can make it difficult to pull wires through the conduit. Use pulling lubricant to reduce friction when pulling wires through the conduit. Do not exceed the maximum fill capacity of the conduit, as specified in the NEC. Overfilled conduits can make it difficult to pull wires and can also lead to overheating. When terminating wires at the sub-panel, ensure that the connections are tight and secure. Use a torque wrench to tighten the connections to the manufacturer's specifications. Loose connections can cause overheating and arcing, which can lead to fires. Label all circuits at the sub-panel to indicate their purpose. This will make it easier to identify and troubleshoot circuits in the future. Use a circuit directory or a label maker to create clear and accurate labels. After completing the installation, test all circuits to ensure that they are working properly. Use a multimeter or a circuit tester to verify that the voltage and current are within acceptable limits. Check for any ground faults or short circuits. Consider future expansion when planning the submain installation. Install a subhull with sufficient capacity to accommodate future loads. Run extra conduits or install larger conduits to allow for future wiring upgrades. Be aware of the potential for galvanic corrosion when using dissimilar metals in the electrical system. For example, avoid using copper conductors in direct contact with aluminum conduit or fittings. Use appropriate connectors and fittings that are designed to prevent galvanic corrosion. When working with PVC conduit in cold weather, be aware that it can become brittle and more susceptible to cracking. Use caution when bending or cutting PVC conduit in cold temperatures. Consider using a heat gun to warm the conduit before bending it. If you are unsure about any aspect of the submain installation, it is always best to consult with a qualified electrician. They can provide expert advice and ensure that the installation is safe and code compliant. Remember that electrical work can be dangerous, and it is important to take all necessary precautions to protect yourself and others. Here is a breakdown of common mistakes people make when doing this job. One common mistake is using undersized conductors. Always refer to NEC table 310.16 to determine the correct wire size based on the load and the conductor's insulation type. Another common mistake is failing to properly ground and bond the electrical system. Grounding and bonding are essential for electrical safety, and it is important to follow the NEC requirements carefully. Another common mistake is overfilling conduits. Overfilled conduits can make it difficult to pull wires and can also lead to overheating. Another common mistake is using incorrect fittings and connectors. Always use fittings and connectors that are listed for use with the specific type of conduit and conductors being used. Another common mistake is failing to properly support and secure the conduit. Conduit must be properly supported to prevent it from sagging or becoming damaged. Another common mistake is neglecting to label circuits. Labeling circuits makes it easier to identify and troubleshoot problems in the future. Another common mistake is failing to test the installation after it is complete. Testing the installation ensures that all circuits are working properly and that there are no ground faults or short circuits. Another common mistake is not consulting with a qualified electrician when needed. Electrical work can be dangerous, and it is always best to seek professional help if you are unsure about any aspect of the installation. In addition to the above, always remember to obtain the necessary permits before starting any electrical work. Permits ensure that the work is inspected and meets all applicable codes and regulations. Keep in mind that the information provided here is for general guidance only, and it is not a substitute for professional electrical advice. Always consult with a qualified electrician or electrical inspector to ensure that your installation is safe and code compliant. If you need to run the SCR cable or PVC conduit under a sidewalk or driveway, be sure to install it at the proper depth to prevent damage. The NEC specifies minimum burial depths for different types of wiring methods. When backfilling trenches, use clean fill material that is free of rocks and debris. This will help to protect the conduit or cable from damage. Consider using a tracer wire when burying non-metallic conduit. A tracer wire allows you to locate the conduit in the future using a metal detector. When installing a subpanel outdoors, choose a location that is protected from the elements. A weatherproof enclosure is recommended to protect the subpanel from rain, snow, and sunlight. Ensure that the subpanel is properly grounded to a grounding electrode system, such as a ground rod or a metallic water pipe. The grounding electrode system provides a path for fault current to return to the source, helping to protect against electric shock. When connecting to existing wiring, ensure that the conductors are properly sized and rated for the load. Use appropriate wire connectors to make secure and reliable connections. Avoid using twist-on wire connectors, as they can loosen over time and cause overheating. If you are working on an older electrical system, be aware of the potential for asbestos insulation. Asbestos is a hazardous material, and it is important to take precautions to avoid exposure. If you suspect that asbestos is present, consult with a qualified asbestos abatement contractor. Finally, always remember to disconnect the power before working on any electrical circuits. This is the most important safety precaution you can take to prevent electric shock. Use a voltage tester to verify that the power is off before touching any wires or components.